What happens when the PC's brain gets a little on-device bot and Windows suddenly remembers everything? For better battery life, faster replies, and yes, one very public privacy scuffle. Welcome to Unboxd Origins. I'm Howie, your resident science geek and accidental trivia sponge.
And I'm Wyatt. I ask the big questions. Sometimes philosophical, often skeptical, always curious.
Today we're digging into how did Copilot PCs and Snapdragon X Elite change Windows? Start with a little scene setting. For a decade, the story of PC evolution read like a tug of war between raw cloud muscle and local silicon efficiency. Big language models live with data centers. Their brains were massive clusters, their energy bills were astronomical, and their latency could be annoying for anything interactive. Microsoft, like several other players, offered Copilot as a window into what those models could do. Summarize, draft, suggest. But usually these operations happen somewhere out on the internet in racks of GPUs. That was fine for many tasks, but it left gaps. Privacy-conscious customers balked, enterprise admins worried about corporate secrets escaping, and mobile users hated the delay when the network hiccuped. Enter the idea everyone kept whispering about in conferences. What if the AI could live, at least partly, on the device? The Snapdragon X Elite didn't appear out of nowhere. Qualcomm had been making inroads into Windows on ARM for years, with the Snapdragon lineage promising great battery life by being phone-derived silicon, adapted for laptops. But the X Elite deliberately pivoted. This chip put much more emphasis on on-device AI, with a larger neural processing unit, matrix vector acceleration, and an architecture aimed at speeding transformer inference. In parallel, Windows evolved too. Microsoft and partners worked to expose APIs, improve runtimes, and refine scheduling so heavier models could run locally without wasting power. The result, for the first time at scale, many assistant tasks could be performed on-device in near real time and with much lower energy cost than a cloud round trip. Microsoft also did something clever on the branding and partnership front. Copilot Plus became not just a software label, but a hardware qualification program. OEMs were invited to design machines where Copilot wasn't just an app in the taskbar. It was a system-level feature that leaned on on-device accelerators, stronger hardware-backed protections, and tuned thermal profiles to keep AI responsive for longer. This collaboration accelerated software optimizations like quantization-aware inference, reduced precision and mixed precision transformers, and memory-compressed models that could be run efficiently by NPUs. In practical terms, a designer could iterate on images locally, a lawyer could redact sensitive documents offline, and a student could get instant drafting help without routing every note to a server. Snapdragon X Elite helped prove those scenarios could be real, practical, and marketable. But then came Recall, which ironically was both the feature name and the headline that made everyone take off their party hats. Recall was designed to be Windows remembering your stuff, automatically creating an indexed history of your activities, screenshots, documents, web pages, emails, and other contextual snapshots. So you could ask, "Show me that slide I was working on last Thursday," and get a direct visual match. It leaned on local embeddings and on-device indexing to make those searches fast. The demo looked magical. The reality was messier. As soon as broader audiences learned that Windows might be persistently capturing visual or contextual snapshots, privacy advocates, enterprise security teams, and journalists started asking hard questions. Where is that data stored? Is it encrypted? Who can access it? Does a single misplaced enterprise machine turn into a leak waiting to happen? The backlash was swift, noisy, and unignorable.
Ah, and here's the twist people didn't see coming. The recall uproar actually accelerated the very change it criticized. By shining a very bright spotlight on what local AI could mean, both the power and the peril, Recall forced Microsoft and OEMs to harden their promises. Suddenly, local inference was a privacy feature in plain sight, not just a performance trick. Companies started marketing Copilot PCs as privacy first. Devices with hardware-protected storage options, clearer defaults, and finer-grained controls. It turned out that a public controversy can be a rude but effective catalyst. It nudged the industry to bake privacy into the silicon and the OS, rather than leaving it as an afterthought in a privacy policy.
The technical consequences of that tug of war were profound. Engineers leaned into hardware-backed isolation. Think hardware-protected stores for sensitive keys and model artifacts, cryptographic attestation so a PC could prove it met Copilot Plus requirements, and per-app policies to limit what context was exposed to on-device models. Microsoft and partners tightened process isolation and lifecycle management to reduce the risk of sensitive data being exposed to models or left in memory after use. The relationship between OS and silicon matured into a partnership. Windows provided the orchestration, model sandboxing, permission prompts, and enterprise policy hooks, while Snapdragon X Elite and similar chips provided the raw ability to run models efficiently enough to make local-first experiences appealing. Economically, the shifts were also interesting. Before, Microsoft's monetization around Copilot leaned heavily on cloud compute subscriptions and service tiers. Copilot Plus PCs nudged monetization outward. Premium hardware could carry higher margins, OEMs could upsell Copilot-certified machines, and enterprises could pay for management tools that controlled how local models were provisioned and updated. It wasn't just about selling silicon or cloud time. It became an ecosystem bet that tightly coupled OS, hardware, and subscription services. This rebalanced bargaining power. OEMs had a fresh marketing angle, Microsoft had new levers for ecosystem control, and chip makers like Qualcomm could sell a narrative of better AI per watt that mattered to real customers.
Aha! But remember this double-edged detail. The recall backlash also taught customers a lesson in reflexivity. People began to demand that the OS explain its memory, not just what it remembered, but why. That demand changed feature design philosophy from "we'll do it for you" to "we'll show you what we did and let you choose." What's interesting is how that dovetailed with technical reality. On-device AI is inherently more controllable. If the model and its indexes live on your machine, users can clear caches, disable features, or opt in to snapshots with immediate effect. The drama around recall forced Microsoft to bake UX clarity into Windows' AI layer, making user consent tactile rather than buried. That subtle human interface change likely did more to build long-term trust than any line in a privacy policy ever could.
There were also second-order effects on apps and developers. The ecosystem of model providers and app creators had to adapt to a hybrid world. Lightweight models for local use, cloud fallbacks for heavy lifting, and SDKs that could orchestrate between them. Tools like OnNX, DirectML, and updated runtimes became crucial for portability. If you could train once and run on both cloud GPUs and a device NPU, you had flexibility. This created an arms race of model engineering. Distillation, pruning, and clever quantization became valuable skills. Startups emerged to produce edge-first models, trained specifically to be accurate yet small. Developers learned to decouple UI from inference location so that user experiences remained consistent, whether the response came from the NPU under your keyboard or a server farm in another continent. Finally, there was a cultural shift around expectations. Users stopped thinking of AI as something mysterious in the cloud and instead expected it as a local, immediate helper, the kind of utility that wakes up with your laptop and is available offline. That changed product roadmaps across the industry. Browsers experimented with local assistant features, productivity suites added offline summarization, and even security tools leveraged on-device models for pattern detection. Windows itself began to feel more like an AI platform. Copilot Plus moved from a standalone app to a system-level capability in how people interacted with the OS. Snapdragon X Elite's early success gave hardware OEMs the confidence to lean into that vision. And the recall controversy ensured the promises would have to be delivered with transparency and control.
Aha! And an ironic outtake is worth noting. Controversy created a trust premium. Firms that clearly documented what they stored how they stored it, and gave users simple toggles for control, found themselves winning large enterprise contracts. The market began to reward openness and local-first processing. In a sense, the recall backlash was a public stress test that revealed weak points and forced an upgrade. It made the industry realize that future AI features wouldn't survive user mistrust, and so they redesigned from the inside out.
So what does all this mean in practical terms? Copilot Plus PCs and chips like the Snapdragon X Elite changed Windows by turning AI from a bolt-on service into an integrated system-level capability. They rewired expectations around latency, privacy, and offline functionality, and forced a rethink of how Windows manages model execution, data handling, and permissions. They also rewrote the economics. Hardware earned a place at the AI table, and models were no longer just the domain of cloud vendors. Finally, the recall episode clarified that delivering AI features isn't just an engineering challenge, it's a social contract. Windows had to show its work.
And from a broader perspective, this was a lesson in technological reflexivity. Tech companies make features. People react, and those reactions shape design priorities. The Copilot Plus story is less about a single chip or a single app, and more about the feedback loop between hardware capability, software architecture, user expectation, and public trust. If the recall moment taught us anything, it's that breakthroughs in capability must be matched by breakthroughs in accountability. Without both, the public reaction will steer the product anyway, possibly in directions less favorable to innovation.
In short, Snapdragon X Elite gave Windows the on-device muscle to make Copilot experiences faster, more efficient, and more local-friendly. Copilot Plus PCs made that capability a marketable, system-level experience. And the recall backlash forced everyone to bake transparency and user control into the mechanics of on-device AI. The result is an operating system that thinks in both watts and ethics.
And that is why it matters. We're no longer debating whether AI will be part of our operating systems. We're figuring out how to make that integration respectful, secure, and useful. Copilot Plus PCs didn't just bring new features. They changed the social contract between machines and users. Windows had to adapt, and adapt it did.
If you like this origin story, give us a thumbs up, subscribe, and share with a friend who loves the hidden history of everyday tech. So what happens when the PC's brain gets a little on-device bot and Windows suddenly remembers everything? You get speed, battery life, and a privacy reckoning that reshapes how the OS itself thinks about memory and consent.